Okay, so we talked about the switcheroo. X's become y's, y's become x's. Well, what that means for the domain and range of these functions is the domain of f becomes the range of the inverse of f. And the range of f becomes the domain of f inverse. That's why the functions have to be one-to-one. So if you look at, I'll give you an example here, the quadratic function, right? That's not one-to-one. If you switch the x and y's, you get this. See, and that's not a function. Not a function. So that's a little problem for us when we're trying to work with inverses and our function isn't one-to-one. However, the good news is we can restrict things so that they are one-to-one. Okay? So remember, to have an inverse, a function must be one-to-one to have, to have an inverse. Okay. An inverse function, I guess. Okay, so now they want us to go through the toolkit functions. It says identify which of the toolkit functions are not one-to-one and find a restricted domain so each function will be one-to-one. Okay, so first up we have the constant function, which is a horizontal line. This is not one-to-one. I'm going to abbreviate one-to-one. There's no way to restrict this one, our first one. There's no way to restrict it because you would have to just have one point, and it makes a vertical line. So there's no inverse here. But we said not everything has an inverse. Okay. So we will look at the identity function. Oh, I forgot to write that up here, what the function looks like. Okay, that's the identity function. It is one-to-one, so we don't have to restrict anything. It's got an inverse. All right, absolute value. That is not one-to-one. So this is our first one where we get to restrict it. So what we're going to do is we want as much of the curve as we can get without it being one-to-one, or without it, not being one-to-one. I'm saying that wrong. But what we're going to do is we're going to cut out this part of the graph. So we're going to just take it out. So here's how we restrict it so it'll be one-to-one. We say, hey, you can have the absolute value function, but x has to be greater than or equal to 0. And so what we've done is we've restricted the domain, and then we said, okay, we only want this half of the graph, and that means it'll be one-to-one then, okay? So it's a restriction on the function, and now it's one-to-one, okay? Now you might be saying, well, hey, I wanted to cut out the other half. You could do that. You could say, here's an alternate way to do it. F of x is the absolute value of x, but x has to be less than or equal to 0. And that would do the same thing. Usually, though, they go with the positive case. I'll just tell you that. Okay? But you could do it the other way. Okay. That was absolute value. So we'll look at our parabola. Our parabola has points like this. The quadratic function kind of looks like that. Should come down a little bit more. Okay. F of x equals x squared. And we're going to restrict that the same way. We're just going to say, we don't want this half of the curve. And so we're going to say, whoops, it slid up too far. x is greater than or equal to 0. So that's the restriction there. All right, so both of those were not one-to-one, and we restricted them. And now we have our cubic curve, which looks something like that. This is one-to-one, so you don't have to worry about restricting it. Let's see, what am I leaving out? I'm leaving out a function. Oh, the reciprocal function. Reciprocal function looks like this. And believe it or not, that is one-to-one. That one looks kind of different, doesn't it? But it is one-to-one. Then we have the reciprocal squared function, which looks something like that. That is not one-to-one. So the function says f of x equals 1 over x squared. And we're going to restrict that by saying x, we have to say x is greater than 0. You can't have it equal to 0 because it's not defined there. Okay. And then I think I just have 2 more. Yeah. Okay, so the square root function. Oh, that's one-to-one. So we're okay with that one. We don't have to restrict it. And then the cubed root function. And that looks like the snake, kind of like that. And that is also one-to-one. Okay, so those are all the toolkit functions and the way we restrict them so they'll be one-to-one so we can talk about their inverses.